Hello guys. Today we will discuss LeetCode weekly contest 488. So let's start. Let's start with problem number 1. 3833. Count dominant indices. You are given an integer array nums of length n and an element is at index I is called dominant if this condition holds. Okay. And your task is to count the number of indices I that are dominant. And the rightmost element is of any array is not dominant. Okay, so in this first example 5, which is like, what is this thing? Okay, if 5 is greater than average of these elements, then 5 is dominant. So we have to count all, like how many elements are dominant. Okay, so in this 4 is greater than 2 plus 1, 3 by 2 equals to, so okay, like this. 4 is greater than average of, like, 2 plus 1, 3 by 2. So 4 is a dominant element, then 1 is not greater than 2 by 1. So 1 is not dominant. So yeah. So just in this, to solve this, we can just apply brute force, like in O of n. Of, like, first of all, we take sum of all elements and a variable answer for to count how many dominant element are there. So we just did this, like, for each element I, we count the sum of all elements after that element, like this. Uh, and we just compare that nums I is greater than the average of all elements after it. Okay, so if this condition hold, then answer plus plus, because we found a dominant element. Okay, so that's all. Like, let's dry run this code on this. Okay, so array equals to 5 4 3. First of all, the sum equals to 5 plus 4 plus 3 equals to 12. So for I equals to 0, uh, what will happen? Like, sum 12, sum equals to 12 minus 5 equals to 7. Okay, because we have to take sum of elements only after the current element. So we subtract our current element from the sum. Okay, so sum equals to 7. So 5 is greater than 7 by 2. So 5 is a dominant element. So just count plus plus and yes, that's all. Okay. So let's move to problem two, problem number two. This is a very nice problem. I got two or three times wrong answer on this problem. So let's see what's it saying. You are given an integer array nums. You must repeatedly apply the following merge operation until no more change can be made. If any two adjacent elements are equal, choose the leftmost such adjacent pair in the current array and replace them with a single element equal to their sum. Okay. After each merge operation, the array size decrease by 1. Repeat the process on the updated array until no more changes can be made. So that's the statement. And return the final array. We have to do just what is statement is saying. Okay. So like for the uh, for the array 3112, like second problem, array equals to 3112. So 1 equals to 1 elements. So new array equals to 3, 1 plus 1, 2 equals to 3, 2, 2. Now, now just we got this 2 equals to 2. Then we have to merge it. So 3, 4. Our new array is 3, 4. And there is no adjacent elements are equal in this array. So this is our final array, like 3 and 4. That is our answer. In this 2 plus 2, 4 and 4 plus 4, 8, like this. Okay. And in this array, there are no adjacent elements which are same. So no operation are performed. That's why this is like that is the answer. Okay. So how can we done? How can we do that? So let's try for this array 3112. We take first element 3. After that we check. We should check. We should check that how many elements are same. How many adjacent element are same? And if some adjacent elements are same, then we can just merge them. Okay. So there is no same adjacent element. So we can just add one. So so no same adjacent. We can just put another one. Then check again. Same adjacent. Then merge. So what will happen? 3 and 2 is our new array. Now 3, 2 and add 2 new. Okay. So again we got same adjacent element. So again merge. So our final array is 3, 4 and 3, 4 is the answer. That is the way. How can we do it? Okay. So let's see code like this. We just take a vector like array answer and we just push back nums I like current element and while we got same adjacent element, if we got same adjacent element then we can just pop back and answer back like that, like we merge, just simply we merge. Okay, like this. This while loop is just for merged. Okay, so just push, check and merge, push, check and merge. Then we got just our answer. Okay, so let's move to uh, problem 3. Count subarray with cost less than or equal to k. This is just a standard two pointer or sliding window approach and problem, like just standard problem. So what is the statement? You are given an integer array nums and integer k. For any subarray nums L R, define its cost as this and return the integer denoting the number of subarray of nums whose cost is less than or equal to k. Okay. So let's take an example like this: 132 k equals to 4. Problem number 3: array equals to 132 and k equals to 4. Okay. So for subarray, like how many subarray can be made by this array? So subarray is 1, 1, 3, 1, 3, 2, 3, 3, 2, and 2. Like these six subarray can be made from this array. So for this subarray, so cost of this subarray equals to 1 minus 1 into 1. So that is 0. Okay. For this subarray cost is 3 minus 1 into 2. So that is 4. For this subarray, 3 minus 1 into 3, that is 6. For this subarray, 3 minus 3 into 1, that is 0. For this subarray, 3 minus 2 into 2, which is 2. And for this subarray, 2 minus 2 into 1, which is 0. So we have to count how many subarray are there with cost less than or equals to k. So there are 1, 2, 3, 4, and 5. Total 5 subarrays with cost less than equals to 4. So our answer is 5. Okay. Same as for this and this. So we can implement like just two pointer or sliding window, just like standard way. Like we just store subarray in multi-set so that we can access max and min element of the subarray efficiently. Okay, so to access maximum and minimum element of the subarray efficiently, we have to store. We can store. Uh, we can store subarray elements in multi-set. Okay, so we just found maximum and minimum element of subarray, then we can just do like if max minus min into length of subarray is greater than k, simply cost of the subarray is greater than k, then we have to make sort that subarray, like we have to remove some elements from the subarray. So we remove from left and add elements from right, like that. Okay. So and If cost is less than or equals to k, then we just add r minus l plus 1 subarrays into answer, because from uh, from the subarray with element 5, we can get total 5 subarrays with cost less than equals to k. Okay, so that's simple, very simple. Okay, this is the code. So let's move on to question number 4. This is also easy and standard problem for DP and okay. So let's read statement. You are given two integer array nums1 and nums2 length n and m respectively, and an integer k. You must choose exactly k pairs of indices I1, J1, I2, J2 up to ik, jk, such that this, okay. So for each chosen pair ij, you gain a score of nums1 into nums2 of j, nums1 of I into nums2 of j. The total score is the sum of the products of all selected pairs, and you have to just return an integer representing the maximum achievable total score. Okay, so let's see how this works. Okay, so let's write first of all a memoization approach like recursion, that is easier than tabulation approach. Okay, so just for each I and j, for each I and j, we have two options like keep like make pair and do not make pair. Only two options. We have just two options like make pair or do not make pair. Okay, so we have two options: make pair, do not make pair. Okay, so in recursion, how can we write this logic? Like see, let's function solve with x, y, and cost. Okay, cost or score, whatever it is. So just in make pair case, we call solve x plus 1 and y plus 1 because we have taken x and y. So we have to call x plus 1 and y plus 1 like forward, and score plus or equals to nums1 of x into nums2 of j. Okay, that is it. And for do not make pair case, we have to call solve x plus 1 and y and do not increase score and solve x y plus 1 with score. Like in this we just ignore like j and increase our I, and in this we ignore our I and increase j. We have just ignore our j element, and in this we have ignore our x element. Okay, so and I'm not increasing score because there is no pair, because I have not made a pair yet, so that score is remain the same. Yeah, that is the recursion approach, and now we can convert it to tabulation form like this. We have to make a dp of x, y, and k. This score also, yeah, you can, yeah, or you have to take k and you have to just pass k because you can make only k pairs. So you have to like bound it. So in this k plus 1 and in this k. Okay. In this, I write k plus 1 because I have made a pair, this, an extra pair. So that k plus 1. Okay. dp of x, y, k. It means like in nums1 array till I and in nums2 array till, oh, not I, sorry, my bad, y. y. I have made k pairs with max score. Okay. Like dp of xyj xyk is denoting this. So now let's see transition of dp. So dp of x, y, k. First, do not make pair. So we just do maximum of dp x minus 1, ignore x, take y and k. dp of x, take x, ignore y and k pairs. And then just dp of then make pair. So dp of x minus 1, take x, take y and pair plus plus. Okay, that's all. And now just we write base case and etc. Now let's, what is the base case? So for x, y with 0 pairs for any xy equals to score equals to 0. For 0 pairs, score is always 0, simply, yeah. That's so I have made 3D with n, m, and k. Okay. So in this ij0 equals to always 0 because score of 0 pairs equals to 0. Then I have just do like ijk equals to I minus, yeah. That's transition, that's simple transition. And our answer is n and k. In array till n, in nums1 till n, in nums2 till m, and for k pairs, what is the maximum score like that. So yeah, it's easy, not hard, not that much hard. Okay, so that's all for today. Happy coding.